Hey guys, how are you guys doing? It's been a while, but I've been working on two cool projects. One for sandboxing AI agents and other software, because the risks with security have increased substantially in the last few months. So with AI being able to identify exploits and all that, so I'm much more aware of security and how to block any software that comes from the outside from messing up with my host, my main machine. And so I'm going to today share some of the stuff that I learned and give you a bit of an overview of the tools that you have available to set up this sandbox. Okay, so let's get into it. So what I set out to do was to add as many layers of protection as I could. I was coming from trying Ramalama Sandbox to run the open code AI agent, but it felt like it was either no network or all network, so it would isolate the AI agent completely. But what if I want my AI agent to have access to, I don't know, maybe a search API or something like that? So I wasn't very satisfied with it, and I started looking into this. I even posted on their GitHub discussion forum about how I could perhaps add some firewall rules. And so I started getting more and more into this. Eventually a friend suggested Nono, which implements the Landlock kernel module, and it also adds some interesting sandboxing rules. It limits the files that the program has access to, or even the TCP UDP connections. But if you run it with open code, you can still, for instance, ping the web, because it isn't able to block, for instance, ICMP. And so I started thinking, what if the AI agent has some security vulnerability that lets it ping my network and map my network, and then somehow exfiltrated this information, which is a security concern. And I'm a bit paranoid level with this. You either secure it or you don't. If you half-ass it, essentially you just have additional overhead that really isn't securing what you are doing. And so I started looking into other tools, and I learned a lot, and this is what I'm going to share with you in here. So what I ended up doing, I found out later, is called defense in depth. So you've got many layers of defense, and as you can see here, these are the layers that I considered. The container runtime hardening, which is the basic container stuff and all, but there are many interesting details with this, so I'm going to get into it. Then there is the Landlock Ruleset. This is essentially around nono profiles. There are other implementations of Landlock, but I use nono. Then you've got Seccomp BPF, which is a way to set rules for system calls. So like read, exec VE, all those kernel level, low level functions. You can use Seccomp to impose limits on this. Podman already has a default Seccomp profile. What I did was essentially try to add extra rules to harden it, and then obviously a firewall ruleset, because with the Landlock I wasn't able to limit stuff like pings, and I wanted to have more control, more granularity over what I can access or not. Okay, Then another friend was talking about DNS exfiltration, really a niche vulnerability that lets you, because the DNS server is usually allowed. If you don't control it, you can, through a vulnerability, eventually exfiltrate information through a regular DNS request. And I'll show you examples on the next videos, but I'm not going to detail it just now. And I also looked at CVEs and implemented a very basic vulnerability management policy. This is just because images, usually if you scan an image, it's got a ton of CVEs, unless it's a hardened image. And of course, we eventually switch to hardened images as well. But let's say that you have some tooling that you need to use, and you really need to use that specific version, but it's got some vulnerability. And you need to know which vulnerabilities are absolutely critical to address. And so I implemented a bit of a policy that helps you with this. It's very basic because I'm not a cybersecurity expert, but what I wanted to do with this was touch each item and do at least some basic implementation of security, so I can build on top of that. So keep in mind, I published the code. It's called Grate. It's on the GitHub for Data Lab Tech TV. But it's not by any means a usable tool. You can use it to learn. Maybe you can fork it and modify it to your needs, but it's very far from being something that you can use in the everyday. This is because, as you can see, there are many items, modules for security that we need to address, and integrating all this is hard work. I'm sure that in the near future some companies will be building tools, maybe using Rust, like Nono did. Nono is Rust, to integrate all of this, and maybe that's what you will end up using. But for now, the system primitives are all available, and you can use them if you know what you are doing. Most of all, what you need for security is awareness of what you can block, and keep a mindset of deny by default everything as usual. But it's hard to find the middle ground where it doesn't hit usability. It becomes, I was afraid that this would become so unusable, so limited, that I wouldn't be able to run any software, but that is not the case. Of course, I had some blocks. I needed to add some permissions, mostly to Nono with the Landlock Ruleset. Firewall rules, I'm very permissive, although I deny some basics by default, and the idea is that this can be expanded, and that's what I was concerned about. So let's take a look at what you can do, or what I did for each of these topics. So for container runtime hardening, I did privilege isolation. So drop all capabilities by default, and then just add the capabilities that you need as you go. To be honest, I dropped them all, and most of the times I didn't need to add that much. I needed maybe something for the Llama server, but as a rule, you can drop them all and then you check it later, right? Then you've got file system isolation. One thing you can do with containers is set your container file system to read-only. You just add the -- read-only, and it's read-only, which means many software that you run inside your container will fail because it cannot write on the regular locations. So you can either use bind mounts for this. So you bind your host directory to a location inside the container, or you can use TMPFS mounts, which is what I used for my home, you know, kind of like what Basite does, immutable Linux does. You know, you've got an immutable part and then a mutable part in your /var for your home and other stuff, so I used a similar approach. Then you've got privilege escalation prevention. This means no set UID or set GID, essentially. If you run it, it will fail. Then I use resource isolation. This is just, you know, to limit the number of CPU cores, the memory that you allocate to your container, and the number of processes that it can run. That's it. You know, just don't let your external software kind of create an equivalent of a denial of service for your system, you know, overload the system. Then I also used identity isolation because for network isolation, the next item, I needed to run Podman as rootful, so I needed to run it as root. And I weighed this for quite a while because I'm trying to remove permissions here and I'm running my container as root. But if I don't run it as root, then the network layer for Podman will not create a proper network interface, and so I will not be able to implement firewall rules. And in fact, this was my original question on the GitHub discussion page for Ramalama. I wanted to know why the hell I cannot, you know, write nftables rules for Podman, and it turns out that if you run Podman as rootless, it's got a different network stack that is not. I'm not going to say it doesn't allow you to write rules for it, but it's harder to do it, so I opted to, you know, just run it as sudo. And with this defense in depth mindset, let's assume that, okay, you are running it as sudo, and then for some reason the software can escape the container. Will it be running as root on your host then? Does it have root? And the answer is not really, because we've got this identity isolation. So this is what this is for. You've got UID and GID mapping, and this is essentially what rootless Podman does when you start it. Your root user within the container is essentially the same as your regular user, your non-root user that you run the rootless Podman with, if I'm not mistaken, but I think that's how it works. So if the user would escape to the host with the root user, it would essentially get access to your own user. I would argue, you know, root, it's having root access is the nightmare scenario, but I would argue that for distros like Basite, having access to your user account might actually be worse. Of course, if they get root access, they can change your configs under / etc. But if they try to change something under /user, of course they cannot, because then this is just for immutable Linux. But you know, this was my way of thinking here. And so I ended up creating some rules for UID mapping. The only issue I have is when I use the NVIDIA GPU, where this doesn't work properly, so I ended up disabling it for that specific case, so only for the Llama server container, which doesn't really run any actions. So in my open code is running on a different container, and that container has UID and GID mapping. So another thing that you should do when building container images is use version pinning, and this means version pinning to the hash. So you pin not only the specific Debian Slim version or Wolfie base image version, but also you pin the SHA, the hash, to a specific hash. This way, if they push another version, with the same tag, you'll still be using the version that you started with. So this avoids, if for some reason someone is able to tamper with the images, this prevents that. And I don't use it everywhere, so I decided I was going to trust Wolfie base because it's a hardened image. It's what they do for chain guard. And so that one I trust, and I keep it at the latest version, because you have to find the middle ground between receiving security updates and controlling the image that you are running. So this is also the reason why I don't version pin all the packages that I install in my system, because if there is a security patch when I rebuild the image, I should get it. Okay. And to finish, use a hardened base image as the default. And I found the Wolfie base image, which a lot of people in the DevSecOps area seems to like. And I understand why. It's just very basic. You can, it's kind of like an Alpine, but with glibc. So you can, for instance, take your base image for Llama server, which has got ton of CVEs, and just copy everything that you need into your Wolfie base. And because it's compiled with glibc, it usually works. I wish I could use Alpine, to be honest, because Wolfie is still tied to chain guard, which is trying to sell this, and I'm a big proponent of completely open source software. And I'm as you know, because I built LiveStore on this same premise, that they ended up closing the source. Essentially, they forked it and kept the continuation of the project private, and so I would prefer that I could use this with Alpine, to be honest, but Wolfie is a really amazing distro. They are very aware of security, so they are doing a tremendous job with this, and so this is what I ended up using. Okay, and as you can see, you can do quite a lot with container runtime hardening. Just with this you can do a lot, right? Then let's jump into Landlock Ruleset. So I ended up doing here was essentially I just call nono run, okay, and I kind of created a bunch of separate nono profiles that I call them nono custom composable profiles, because I essentially have this Grate.json profile, which is the profile that is used when I run nono, but it dynamically extends some other profiles, which can be the Grate GPU profile or the Grate CDev tooling profile. You catch the drift. And so this lets me control directory and file access. You can set read and write permissions. You don't really worry about execution permissions. They had something for this previously, but what they suggest is that you just control read access, and then you won't be able to execute it. And then you can also control basic TCP and UDP access. By default, if you allow a domain, you can connect to any port, but I found out they use a proxy internally, and I found out that the proxy doesn't really work well when you are trying to connect to plain HTTP. So I ended up having to set up certificates within the base container, so that I could provide Llama server under SSL. And then it worked fine with nono. Then you've got Seccomp BPF. This is very simple. You just have a bunch of syscalls that you either allow or then deny with an error or something like that, and the software will try to run and it gets an error saying this is not available for some reason. It ties to the regular workflow, the regular API workflows so it doesn't break your software, just get an error. And I extended the basic Podman profile with just a few extra rules. But you know, I've got the system in place. I can extend this. I can create different profiles for different software that I might use. I might even drop the default Podman profile because I have to fetch it from under /user share containers. There is a seccomp.json. I have to fetch it from there, edit it dynamically, and add my rules. And then I use that profile. There is no, you know, extension mechanism. It's just either this profile or that profile. So I can drop completely the profile from Podman, just use my own if I want in the future with tighter rules. Okay, so then I used Firewall Rulesets. I used nftables for this, the pure nftables. I considered maybe Firewall CMD, but you know, it's just an extra layer that I didn't want to add. The firewall is running on the host machine, and it does require sudo to set up the rules. So essentially you get a table inet, which inet, so nftables is divided into tables. You can give it a name like Grate, okay? And you will find that if you are running Firewall CMD, you'll see a Firewall D table as well. You'll probably see a Podman table, a netavark table. And so I create this table, and then within this table you can define different chains. Usually you get the input, the output, and the forward chain, and then you add rules to these chains. And so I essentially drop all IPv6 traffic because, and as I say here, IPv6 doesn't have network address translation. And so if you've got hardware running in your local network with IPv6 enabled, and it really depends whether your ISP supports IPv6 and your router and everything, you know, up to the machine that you want to access. But if you do have a clear path to the web and you are using IPv6, then from what I understand, and I have never used IPv6 to be honest, but from what I understand, your machine will essentially be visible to the public. So if you can use IPv4, just drop it, and you know, for local network you can definitely use it. So everything that is IPv6 is disabled. Then I drop traffic to link local and private IPv4 ranges, and I accept traffic to hosts and ports listed in the whitelist.conf, which is a file that I created and is shared by the firewall. It's shared by nono, so all the hosts and ports are extracted from there and added as allowed domains to nono. And I also use it for the DNS Server Allowlist. So I added this because of the DNS exfiltration thing. So I replaced the default DNS server from Podman. This is when you create your network, there is a --DNS and you can set it there, and I set it to another container which is running unbound, which is the DNS server that I ended up using thanks to a suggestion from a good friend who also likes all this system engineering stuff and cybersecurity. And so I also use the allowlist to determine which hosts can be resolved by the DNS, and this is what is actually preventing DNS exfiltration. And I can also add some custom DNS entries, like for the Llama server. Okay, and this DNS exfiltration, just quick summary, this is just, you know, some bad actor controls a DNS server for their domain, and they end up in introducing a vulnerability where they resolve a subdomain for their domain, so it will eventually go to their DNS server, and that subdomain is essentially data that you want to exfiltrate. It can be encoded as base 64 or something like that. Imagine a password or something, and it will be logged into their server, and essentially they get the data on their side, and this is what we are trying to, you know, defend against here. And then, like I said, I created a vulnerability management policy. I use Grate for CVE scanning, and then the policy is essentially just this. I check whether the CVE is listed on the CISA KIV catalog. If it is, this is absolutely critical. It means it's being used actively on exploits that exist right now. So if you see this, then just, you know, address the vulnerability. And then we use the score thresholds for EPSS above 0.7, CVSS above 9. CVSS above 9 is just, you can consider it a warning. Like I say here, none of this is automated yet. My idea is just to run this after image building, but for now I haven't really thought about how I'm going to, you know, integrate this, so I haven't added it. If you want to do it, run after you build the images, so just build. You can run just scan, and it will scan, and you can choose to the mode as raw, where you'll just see the output from Grate, or the mode as policy, which implements this policy that I just described. Also, it's frequent that in a policy use the software bill of materials, the SBOM, to tell you exactly what is being affected, the specific files. And then you cross-reference this with your CVEs to determine reachability, and reachability would also be integrated into the vulnerability management policy. But I didn't do that because that's just a pain to implement. You need to implement it specifically for, let's say, for your Python software, if you are doing Python, specifically for your Rust packages. So it's not something that you can very easily implement, as far as I know. But like I said, I'm not a cybersecurity expert. I'm sure you guys that work on the area know a lot more than I do. And so this is essentially what this defense in depth, the layers for this were implemented on Grate, which is available. It's just a bunch of just recipes, think, you know, small bash scripts, and it's not, like I said, a tool that you can use directly, but you should be able to use it with not that much effort. If you want to try to run open code with it, you can run just build and then just open code -w your workspace, and you should be golden. Of course, you might have to edit some Grate.json policies for nono, or maybe some seccomp syscall policy. I don't know. It really depends on your use case, and if it blocks what you are doing, well, it means it worked, okay? And so I'm going to show you a bit more detail on this, with just show you some websites that you can consult to know more about this, okay? So this is the project. You'll find it under github.com/datalabtech TV/Grate. You'll find all the code here. The main entry point is a just file, which is the way I use to orchestrate all of this, okay? If you want to do a quick start, just follow this, okay? This will, you know, give you the basics. As you can see here, I've got just build with debug tools, with CDev tools. The idea is that I will have different profiles that I can add to the base image, and everything is extended from the base image. So if you do this, everything will essentially have this in their image, which is not ideal, but you know, it's something to address in the future. Try to separate this, maybe add these flags to just the build open code or something like that. But for now, this is how I'm doing it. There are not many CVEs that are introduced with this. It's like 4 or 5, and they are not very critical, so it's not that worrisome anyway. And so you can do something like just open code /w or -- or -w or -- workspace, and then you just give it a directory. This will be mounted under /workspace on the container, and then you just, you know, do your usual work. This will launch Llama server with the default model that I'm using. I'm using Quen 3.5 with 4 billion parameters, and it's quantized. I'm using Q4KM. I don't know what it is, to be honest, but it's a model that is small enough that fits in my machine, and I think I have some more VRAM, but you know, this is a good default for us to try. And I will of course continue looking into this now that I feel a bit safer. I've got my sandbox, so I'll continue working and learning about AI agents, because you know, I can say that I love it, but it's unavoidable, and it's at the same time I have many mixed feelings about this. It's a love-hate relationship. Some days I absolutely hate it. Some days I find it amazing what we can do with it. But one thing I know is that every computer science professional must learn this, and then you can do whatever you want with the knowledge. But yeah, I don't think we can escape it. But I'm going to keep working on my skills outside of using AI agents. That AI agents is just another skill that you get, in my view. But yeah, anyway, you can run this. I've got some tips of the files that you can look under if you want to try to debug this. Some of these files are dynamically extended, and they will be dropped under the workspace directory under the Grate. So this directory over here, under the root of this directory, some of these files will be extended and dropped. For instance, the Grate JSON for the nono profile will be extended with whitelist domains. And so we've got everything that I just used to present this. You've got it here. It's a README. I recently switched to Emacs, so it's my first org mode README, and I absolutely love it. I am now a part of Church of Emacs, and a video will be coming about that. It's unavoidable. Anyone that uses Emacs just loves it. Come on. I was using Z before, but you know, I wanted something that was non-proprietary, and yeah, you know, I finally switched to Doom Emacs. I'm one of those evil mode guys. I was using Lazy Vim as well, so you know, I use them both. There is no Vim versus Emacs war anymore in my mind, in my heart. I like them both. To be honest, I always did. Anyway, you get some of the story here as well. And then you can check to understand all the technologies that I used. You can check these pages, so you can, and I will add them to the description below. You can check Podman network, and you must run it with sudo. And some of the options that I use are --DNS. I also use subnet to define a specific subnet, so it makes it easier for me to use IP addresses if I need to. Because for instance, for Llama server, you know, there is no way to assign static IPs if you are using this dynamically, and so I just use an end of the range IP for Llama server, so it's .200, and I assign it statically, so I need to know which subnet will be defined when running the Podman network. If I don't define this, then each Podman bridge interface will have its own network, and it really depends on what you are running in the system at the time. So this is for Podman run. All the flags that I used will be here, like UID map. This is just the man. You can run man Podman. I like the command line, but this is just easier for me to organize for the video. But I never really used the website, just use man, and that's it. And there's a lot of stuff that you can do here, like define your TMPFS with read only or read only TMP, and you can learn all about it here. Then we've got Landlock. There is a website from Landlock, and in here you'll find the integrations, and nono is one of the integrations or the implementations of Landlock that you can use. In here you'll find an overview, and I believe there is some documentation where you can actually see the access control policies or rules that you can implement quite clearly at kernel level. And then you can also check the website for nono. It seems like many people like nono in general. I've seen it recommended at least in 2 different places, from a friend and then online as well in a discussion forum from Ramalama, which is Red Hat people. They know about their servers, their systems, their security, and you will be able to access the documentation. Nono exists for Python as well, for Rust, and I'm using it in the CLI, so this is the manual page that I'm interested in. And you should take a look at profile authoring, and in here you'll find everything that you need to know about the JSON profiles. So it's our Grate.json. So now about Seccomp. I found this blog post from Podman from 2019, which teaches you how to set up a custom Seccomp for your Podman. So you need to install this OCI Seccomp BPF hook. This is, if you are on Fedora base, this is on the main repos. Otherwise, it should be available for your distro. And then you just need to add this annotation. Sorry, this is not the annotation. So you need to add this security op with seccomp equals and your host JSON file with your policy. Okay, and this is what we created with seccomp.extra.json. This is added to the default Podman profile, which is available on your system under /user share containers seccomp.json. And so, as I just told you, you need to install this, okay? And I also found this blog post by Nawaz Dandala, which had some examples of the JSON structure. And so, for Seccomp BPF. And so this is what you essentially do. By default, you use usually the Podman policy uses this seccomp action error number, so it means that these syscalls will result, or rather the syscalls that are not covered anywhere else will result in an error, so it's denied by default for system calls. And so what I did was define some explicit ones and remove them from any except or any other rules that exist and just deny them completely. It was just like 4 rules, but I will go into detail in future videos on how I implemented each part, so you don't need to be worried. But if you want to do it yourself, this video should be enough. Then for the firewall, I implemented a bunch of rules. You can check the wiki for nftables to learn all about the rules. I think this is the most comprehensive. Other than the man pages, this is the most comprehensive one. You'll learn about tables, chains, and rules. Okay, and also I was talking about that you need root to be able to filter this, and this blog post should also add some more information about how Podman networking works. So rootful networking is different from rootless networking, and this is something that is important for you to know. I don't think it's quite well covered, to be honest, and I still don't know exactly what I can do as rootless. I think that you can run Podman. I think it's something like unallow or something like that. But I wasn't really successful in using it, so I'm running as root for now. Then for DNS, I'm using unbound, and specifically I'm relying on local zone to deny, the period. With this type will be I think it's deny or something like that. Yeah, it's deny. So I deny everything, and then I allow some specific subdomains or domains that I want. And in here, this is the blog post that my friend shared with me, so thank you. I am Kira. I think I can use that name because it's public. And this is explaining what DNS data exfiltration is. I had no idea that this existed, but I went paranoid mode and had to to solve this. He also recommended unbound, and I ended up using it. I checked whether the Podman DNS, which is Avark DNS, which is part of NetAvark, if it let me do this, and I don't think it does let me do this, so I ended up doing something custom. I actually prefer it because I like to have control over my stack. I also think that it's better for security that you do something custom, unless of course you don't know what you are doing, and it might be my case, I don't know, but I think it's better because with supply chain attacks it's much easier to just identify a module for security that everybody's using and then attack that module, right? And then for CVEs, like I said, I used Grate for my scans. It looks something like this. So when you run just scan with mode raw, this is what you will get for your image. It already has some scores and all that, but what I really use is this JSON format that they are showing here, and then I extract some values to determine to if it matches my vulnerability management policy, essentially. And one of the things that I use is this list of non-exploited vulnerabilities, so the KEV. So this is the CISA KEV catalog. When people talk about this, and I didn't remember what the acronym stands for, but this is what it does stand for. And if something is listed here, this is an immediate red flag. This is the maximum panic that you should have for a CVE, because it means it's being actively used for some exploit. This is why it's listed on this list. And so this is the number one criteria for our vulnerability management policy. And that's it for today's, guys. Hopefully this was informational and you learned the basics of what tools you have available to you to help you strengthen your sandbox and protect yourself in a world where we have supply chain attacks every day, and you don't want to remove all your root file system like we've been seeing many people do. I don't know why they do that. If you don't want to trouble yourself with all these layers, you can simply run your stuff inside a container, or you can run it with nono at the very least to protect yourself, and it's quite easy to do so. Nono already provides a profile for the main AI agents anyway. You got a profile for OpenCode, you got a profile for Claude, so there really is no reason not to protect yourself. But if you want to go the extra mile and be a bit paranoid level like I'm being here, then you'll want to use a lot more tools, and you will want to harden your images and reduce your attack surface by removing packages that you don't need, denying stuff by default that you don't need to expose and all that. So anyway, next time I will cover each of these in detail, each of these layers in detail. I'll show you some examples of how stuff impacts how your changes to the container, if you are talking about the first layer, will impact your runtime. For instance, what does read only do and how do you handle it, what types of problems will you hit when working with the stuff. And so expect a few more videos coming with for each layer, maybe little bit less if it's too little content. And in the future I'll also be making a video about my whole process, because like I just showed you, I switched to org mode. So you know, the obligatory Emacs Church of Emacs video is coming. And so stick around, I'll see you next time. Keep building our systems engineering skills.